Fine, so here is the start of the video solution for the physics standard level paper, time zone 2 for May 2010. Now, just by way of introduction here, you can use your data booklet, so it's important to have your data booklet available, and also it's good to realize that these papers are set in quite a consistent sort of order. We have for Unit 1 usually questions 1 to 3, Unit 2 questions 4 to 8, Unit 3 questions 9 to 11. This is usually how it works. Question 4 12 to 15, Unit 5 16 to 18, Unit 6 19 to 21, Unit 7 22 to 24, and Unit 8 we have from 25 to 30. So as you're going along, it's quite good. So for instance, here we're doing these 3 questions would be for Unit 1. Have your data booklet open for Unit 1, and then when you go into the second one, move your data booklet over to correspond, and that way you can always be referring to your data booklet. Also, it will just perhaps direct your mind in the right direction for that. Okay, so we're going to go through this in quite a lot of detail. I'll read through all the questions and we'll discuss them. So for question 1, the current in a resistor is measured at 2 amps plus minus 0.02. So this is plus minus 0.02 is your absolute error. Which of the following correctly identifies the absolute uncertainty and the percentage uncertainty in the current? So this represents that your percentage uncertainty is that absolute divided by that, so that's going to be 0.01. That would actually give you what we call your relative error, and when you multiply that by 100 over 1 by 100, you get your percentage, which is 1%. So we're looking at there and there, so the answer is A. Good. Now, in the next question here, you're going to see the importance of reading very carefully. You've really got to be alert, and that's why it's always important to have a good night's sleep before. But for instance, this one over here, it says, which of the following lists only 2 vector quantities? Now, to be quite easy when you're reading here to miss this out and just read it, which of the following lists vector quantities, and to forget that you're only looking for 2. Because this one over here is your correct answer. Momentum and displacement are vector quantities, so there you got two energy. But here we actually have all 3 of these are all vector quantities, so it's likely that you would put C. So they're really trying to trick you here, which is a little bit unfortunate. That's not supposed to be. But the importance of reading very carefully when you're doing these problems. Question 3, Samantha walks along a horizontal path in the direction shown. The curved part of the path is a semicircle. So if this is 2, then basically if you were looking there, that would also be 2, and that would be 2. So you're going to have a 2 and a 2. The magnitude of her displacement. Now, displacement is the direct distance, or the shortest distance from the start to the end. So that would be a total of 8. If they ask for distance, if they said what the distance would be, then you would have to have calculated that half circumference of that circle and put that in like that. Alright, so your answer is D there. Good, let's move down here to these questions. Which of the following may be determined from a speed time graph? So we've got our meters per second here, and we've got our seconds. Now, you can either be looking here really at the slope or the area. Alright, so if you find the slope, then you're going to have your meters per second divided by second, and that will give you a meters per second to the minus 2, which is an acceleration, but there's no acceleration there. If you're finding the area here, then you're going to be multiplying your meters per second times by your second, which will give you a meter value, which is a distance value. Now the question is it displacement or is it distance? Now because you're talking about a speed time graph, it will be distance, because speed is a scalar, and so therefore it would be a scalar. If they spoke of a velocity time graph, then displacement would have been the correct answer. In this next question, let's read this through carefully. It's Stephen pushes 2 boxes P and Q that stay in contact along a rough table. The rough means that friction will be involved, with a force of 30 newtons. Box P has a mass of 2 kilograms and box Q has a mass of 4 kilograms. Both boxes move with constant speed. Now, this is the really part. And again, if you don't read carefully, you could well get mixed up here. Constant speed. Therefore, when it asks what is the resultant force on Q, because it's going at constant speed, it must be 0. Because if it wasn't a resultant force, if there was a resultant force would be greater than you would have a resultant force if this was accelerating in some way. Okay. Fine, going down here to this one. We look at question 6 firstly. We have a ball moves along the inside of a horizontal semicircular ring as shown. The direction is a view from above. Which of the following best represents the direction of the average force? Now, with circular motion, when you have circular motion, and this is part circular motion because your force is always directed towards the center. And that's your centripetal force. It's always directed towards the center like that. So you would have B, where it says which arrow represents the average force. Well, if we think of it, we've got that force there, we've got that force there, we've got that force there, we've got that force there. These two will cancel out. Your average force will be in that direction over there. So we would expect for 6 that it would be B would be the correct one. Question 7. A ball is thrown vertically upwards and it comes down again. Air resistance is negligible. Which of the following graphs shows how the gravitational potential energy EP varies with time? Now, let's just think of another formula. And by the way, I should really have moved down here, shouldn't I? I should be on this one over here, because this is my formulas that I have for Unit 2. So I've got these formulas over here. Now, in dealing with this question over here, your gravitational potential energy is this one over here, isn't it? You see that your EP is equal to mgh. Now, that's not giving me any relationship between EP and time. We're looking at what's the relationship there between those two. Now I do have an h here, and in this case your h would be your distance, and if I have a look here, I've got a s value there dealing with time there. So your displacement is equal to deal with time. So here I can see that my s there has got a squared term. So we would be expecting some sort of parabola. The shape of this is a parabola. So if I have a look at this here, EP, I'd be expecting some sort of parabola shaped graph. So we would be expecting this. Obviously, because it's thrown vertically and it's depending on your height, you would expect your EP to increase and decrease. So you would be looking at something like this one. This one would not be correct, but you'd be wondering which one of these. Now, because we've got this relationship that this is the shape of a parabola, or it's a quadratic function, it's the shape of a parabola, we would be having D would be the correct answer for that. So 7D. Here we have a pump extracts water from a well of depth H at a constant rate R. What is the power required to raise the water? So again, here we've got our energy that we're putting in is NEP. We're going to have an increase of energy is equal to EP, which is mgh. Now we've got that. Now this is R kilograms. So R is what we're going to have is a kilograms per second. Now we know that power will equal your energy divided by time, so it will equal a joule per second. A joule per second. Now this is a joule, so if we put in our R here, it naturally, if we put in our R there, we're actually going to get a joule per second, so it would be this one over here. I hope that makes reasonable sense to you.